So this is meeting 4, which is SolidWorks 3, the last of the 3-part SolidWorks training. So real quick before I get started, I just wanted to ask if anyone had any questions beforehand. Oh God, it washed me out a ton. Yeah, you guys can put it in the chat if you do. Actually, it won't show me the chat right now, so I'll have one of the other mentors tell me if so. We good?
Yeah, no one's mentioned.
Cool,
anything.
Great. Alrighty.
Oop, we got one question from Harrison. How proficient do we have to be at SolidWorks at the end of this training?
I mean, that's a little bit hard to answer because I can't quantify that. Basically, use the training to improve your skills. We're not asking you to be, perfect at SolidWorks. That's by no stretch an expectation. But this is just to kind of boost your skills, and then any additional questions or help that you need going forward, when we're actually doing the actual challenge itself, then your mentor can help you with that. So don't worry about it too much. If you've done the training, then you're at the level we expect. Also, I'm just turning down my monitor brightness so that I'm not so washed out. There we go. Cool. All right. So overview of the night. So we went over questions first. Zoom waivers is going to be next. We'll talk a little bit about some other administrative stuff. Refresher on Diva Drive. Some CAD tips and notes. Then Bryce will talk about assemblies, and then we'll go into the breakout rooms, which will be the majority of the night. The presentation stuff shouldn't take too long. So Zoom waiver. So I mentioned this earlier, and I mentioned this last week as well. So we've gotten a little bit more information about this. I'm going to drop this link in the chat. Here we go. So some of you have already done this, but for those of you who haven't, we just need this waiver to be signed for Northeastern's legal department to accept us recording these and posting these to YouTube. Again, the point of us posting YouTube is just so that other people who either missed the meeting or missed the cutoff for signups still have the opportunity to learn this content, and so this stuff's all documented and can help someone else. But I wouldn't expect much traffic. But yeah, the waiver is just saying that we are allowed to record. That's all. And you can just type your name instead of like printing and signing it. You can print and sign and scan it, but you don't have to. So, and then save it as a PDF, please, and then put it in there's a location on there of where to put it as well. I think it's like the place I sent to you is, yeah. So this is where the template is located. And then if you go into intro waivers, Mechatronics, you can save it in there. So cool. That's that. So if you guys can have that done before next week, that would be awesome. I'll be checking periodically and marking you guys down. So as next meeting approaches, if you guys haven't done it, I'll shoot you a message to remind you. All right, cool. Next thing, cameras. So in the big meeting or whatever, it's not a huge deal because it's pretty much just a lecture style thing at the beginning here. But when we're in the breakout rooms with your mentor and your teams, we are going to ask that if you have a camera that you do turn it on. It's not meant to be like any kind of intimidation or anything like that. It's just so that people can have more natural conversation and discussion. And we think that it helps keep things it helps keep everyone engaged. And note, this is not part of the meeting that will be recorded. So it's really just for discussion purposes. All right, the Diva Drive. So we started working on this last week, and we'll continue working on it this week because I don't think anyone finished, which was totally fine and mostly expected. So there's the modeling task, which is the 4 parts that we're modeling from the drawing sheets. And then after that, you want to download the hardware, the screw and the nut used in it from McMaster. We touched on this last week. I think we go over that again this week. Then you're going to create an assembly, which is how you, when you put the parts together in one CAD file to check how everything goes together. Bryce is going to touch on how to do that later on in this presentation. And then an optional step is to add customization. So for those of you who get done with this before the end of the meeting, you'll have the opportunity to, you know, tweak the design, add in like your initial somewhere or whatever you want to do. If you want to change it up a little bit, the only request is that you don't make it dramatically larger than it is now, because we are trying to print one of these for all of you guys. So make any modification you do reasonable, I'll say. And if you have a question about what reasonable is, just ask. And then throughout all of this, please save to GrabCAD. You don't have to push to GrabCAD all the time, but make sure that you're saving to your computer in the GrabCAD location. And then at the end of the night, push to GrabCAD. If you want to push to GrabCAD all the time, though, go ahead. All right, I think I'm going to pass it off to Bryce now for some reminders and new information about CAD. So I'll stop sharing. All right, I just turned on the settings so you can share, Bryce.
Okay. You'll see my screen?
We can.
Cool. This was where we were at. All right, so picking back up from where we were last week, I just wanted to go over a couple of things about some of the parts that you're going to be making. So blue sketches are those undefined sketches. So like the sketch on the right where you've got some blue circles and rectangles and stuff, those can be dragged around. They're not fully defined, so we want to avoid that. In all the drawings that we're giving you, you have all the dimensions. You should be able to fully define all of your parts. If you're for some reason having issues with that, your mentor should be able to help you out. And then we also have some tricky sketch elements that we're advising you to avoid because they can break, and usually there are feature-based alternatives that are a little bit more robust. So those are sketch mirrors, sketch patterns, and then anything that you're fixing, we would recommend not doing that because it can tend to not work if you need to change your design. All right, so theme of today's training session is what are assemblies? So when we're doing CAD, we do that so that we can make our parts and use machines to make them or whatever. But also we're just trying to plan out our designs to make sure that they're going to work. So one of the biggest things that's really helpful with that is making an assembly so you can put all your parts together and see how they interact with each other. And usually this is where you actually catch a lot of your issues in your design. So for example, I might see that my screw pattern doesn't line up, so I need to update that in my CAD. Or I might see that some parts are going to interfere, they're going to rub and wear out quickly. So I'll catch that at this phase. So you're basically just specifying how your parts are going to be going together. This touches that. These two cylindrical objects are concentric to each other. That sort of thing. All right, I'm going to try to share my SolidWorks. That work?
Still see slides.
Okay, how about now?
Yep, you're good.
Okay, so in this, I've created a new assembly. Actually, I'm going to drag this down so I can see all my top bars. With no parts in it. So the way I would get to this screen is I'd go up to this new tab and I'd see either these things from an existing part, or I can click on this kind of paper looking thing. It'll bring up this dialog box. I'm sure you guys have seen this now by this point, but I just want to touch on it again. You could hit OK, and that would create a new assembly. Actually, let's do that really quick. So when I create a new assembly, it will bring up this dialog box for me to start inserting parts in. So when I go over here, I can either pick some files that I might have open that SolidWorks thinks, okay, he's got some parts open, he might want to put these into assembly. Or I can browse into my file explorer and try to find some parts that I want to enter into an assembly. So in this case, I'm going to actually pull out some of the parts that we're going to have you guys model later. And then this will let me start placing my parts in. So this dialog box is actually really important when you're coming in, because the first part is usually one that you want to keep fixed to the origin in some way. What I mean by that is, imagine you had your parts floating around in outer space and they had nothing to actually tie them down to anything else. They're just going to be completely free. But if you're actually rooted to something, like if you could say, keep this thing absolutely fixed in space, then you would be able to base all of your other parts on something that's actually fixed instead of being all wishy-washy. So when we have this, we have our first part, and then we can actually, if we don't like how this is set up, we can actually like rotate it around to try to get the right orientation that we might like. In this case, I actually did like that, so I'm going to get it back there. But you can basically rotate it around however you feel like to get whatever orientation you want your assembly to be set up as. All right, we're going to go with this. And then at the end of this dialog box, I think the easiest way to get this rooted down is to actually hit this green check mark. So what that's going to do is it's going to automatically for you fix your first part in. Usually the first part that you want to add in is your kind of central big part. It doesn't have to be, it can be any part you want, but usually that makes sense. In our case, it's usually we're making a rover or a lander or something like that, so it's our big body chassis section. You can also tell that it is fixed because it has this little F in parentheses, and that'll let you know that you're completely good to go on that. All right, so if I'm going to insert some more parts, I can maybe do the other frame half. And then when I insert those in, then I can place them in, and it doesn't have any relations now that tell it where to go in my assembly. So right now this is floating around, but this part, because it's rooted at the beginning, it won't move around because it's completely defined. You might also see sometimes a little box pops up that says it's fully defined, it cannot move. But yeah, so this is fully defined, but this one is allowed to move. So now I need to start telling SolidWorks some rules about how I want this to be constrained. So I'm going to go up to this paperclip looking thing and hit the mate button. And then that's going to bring up this dialog box on the side that has a couple of different options for how I can put these together. So in my case, I want these screw holes to line up because that's how I'm going to actually attach my parts. So I'm going to press concentric and put these guys together. And now SolidWorks has constrained these to be concentric to each other. But then this also isn't the way that I want them to go. I actually want them to be kind of flipped the other way. So I can also go down to this box down here, and when I do that, it will actually flip it around to be the right way that I want. So now SolidWorks knows these things should always be concentric to each other, but it's still allowed to move in the ways that I haven't constrained it yet. So now I'm going to do the same thing with the other screw holes so that those are aligned. And when I do that now, this won't actually be allowed to spin anymore. It can still move in this way, but it's not allowed to spin around because I've constrained it kind of in two directions. All right, so something that you've seen is that I just kind of have been selecting these, and SolidWorks is pretty good at guessing what I'm doing. If for some reason it didn't pick the right mate here, you could always try to pick another one. So let's say I wanted these to be a certain distance apart. I can switch which mate SolidWorks is guessing. In most cases, it's pretty good. Sometimes SolidWorks can be dumb. I'm sure it's happened to many folks. But yeah, so for some reason I wanted these to be like a 1/4 inch apart. I could set that, and SolidWorks would also set that relation. So I'm actually going to keep coincident here, just because that's what I care about. Cool. All right, so I guess the last thing I want to touch on when we're talking about doing assemblies is that because this is part of your design process where you're trying to iron out all your details, I would highly recommend trying to make your mates as close as possible to the way you actually want them to be. What I mean by that, how you want them to be in real life. What I mean by that is, like, I'm going to have screws going through these holes. So that's how I decided to constrain this part, because I know that I'm going to want screws to go through these. So those should be aligned. If I decided, oh, well, you know, these two things are coincident, these two faces, and those two faces are coincident, that might also constrain my parts together in CAD, but that might not help me catch details that I would overlook, like maybe my screws won't line up when I'm actually going to put them in. So make sure you're thinking about how things would actually go together when you're doing your assemblies, and that will probably help you find more issues. All right, that's pretty much what I have for showing some assembly stuff. I'm sure you guys will get to dive into this today if you do finish your part modeling. But we can jump back to the PowerPoint now. Okay, can you guys see my presentation screen? Yep, okay. All right, so these, another thing that I want to show you guys is, we kind of touched on this last week, but we can also specify parts based on McMaster parts. Let's see. All right, so if I'm in McMaster, I can start specifying certain hardware that I'm trying to find. We did screws last week, I'll look for nuts this week. So there's a million different options for different things you can find. In our case, we're just looking for basic screws and nuts so that we can make sure that our assemblies are good to go. So I'm just going to go through the interface here. I'm just looking for, you know, regular run-of-the-mill nuts. Generally, when you're specifying stuff on McMaster, you want to go as general as possible. In your case, you want an M3 thread. So usually metric stuff is at the end, unless I went to the wrong thing. Yep, so I'm going to specify an M3 thread, and then I just want regular run-of-the-mill nuts. So I'd be able to go here and then save this file in the right location. And then, like we were saying last week, that right location is always going to be in this GrabCAD folder, so that when you're sharing files with other folks, they can also access those parts. Otherwise, you know, we're looking through your SolidWorks will be looking for your download folder, and no one has access to your local files. All right. Let's go back to presentation. Okay, so we kind of went over this in the show and tell section, but basically when you import parts, you want to make sure one is fixed, and you want to keep your other parts floating. SolidWorks will keep as many constraints as you set. So if you want certain degrees of freedom, it will still be able to drag your parts around to see how they move. But if you set those, they won't be able to move. We covered some basic mates. Essentially, you can go through and say, you know, I want these two things to be concentric. I want them to touch. I want these to be a certain distance from each other, parallel, perpendicular, what have you. It's pretty similar to sketch relations in a way, because you're just saying how certain geometries should relate to each other. And then another thing we want you to keep in mind is that while you can edit parts in assemblies, this can create some dependencies between your parts, which when changed tend to break pretty easily. So especially when you're starting out, this is something to be careful with. So we don't really recommend doing that. And then also in the assembly view, similar to the way that you can control your features in a part, you can also use the feature tree to find your different mates between your parts. All right, so some advanced mates that are good to know about, but you don't have to use certainly, and they're always good to learn later, are a few of these. So you have width, that basically puts two surfaces in between another two specified surfaces. So if you wanted this part to be directly in between that one, you could specify that. Limit mates are good. If you, let's say you have a joint that wants to move on a hinge, but it can't necessarily turn all the way around, you can set it so that it's stuck between a certain set of angles. And then symmetric is another one that's pretty useful. That is if you have a plane that's directly in the middle of one part. So let's say there is a plane directly in the middle of this part. I could say that that should be right in the middle of these two surfaces as well. So it's pretty similar to width. It's just if you have a plane that already exists in there. And then there's many more complicated mates that we won't get into. If you ever have a use for gears or something like that in your mechanisms during your design challenges, I'm sure we can incorporate that in either with your mentor as a group if a lot of people are running into that. It's just a lot of useful ways to constrain parts that you're going to be designing into your assemblies. So yeah, now we're going to try to get into our activity. That's going to be the remainder of our time tonight. So that's just modeling all of these parts that are located on the drive, and then trying to, if we get them all modeled, putting them into assemblies, and then just doing what you can. I'm gonna pass it off to Scott now.
Great, sounds good. Thanks, Bryce. So, yep, we're gonna move into breakout rooms now. Unlike last time, I actually created the breakout rooms while Bryce was talking. So now you guys don't have to wait 5 minutes while I do that. So we're learning here. All right, so I'm going to open those in a sec. Same groups as last time, as they will be through the whole semester. So yeah,